Hey guys. Yeah, I divide once by the length of V0 because I'm taking the dot with the normal V0, which is has the same length as V0, of course. But I want to project A0 onto the direction perpendicular to the velocity, which is the dot product if was the unit vector, but it isn't. So we have to divide once by the length of V0 in order to get that projection. And then I'm dividing it again by V0 because I forgot. I thought of this while walking in the forest today, like a few hours ago. No, cannot remember it. Pretty sure this was the right formula. I'm going to plot it so we can see what it is. Substitute, plot acceleration, which was not very interesting. Plot curvature. That is yeah. Oh. That's the reason. Because I'm going to multiply it with that same vector. Now clearly you have to divide twice by the length. Yeah, it's just stupid. I mean, basically I want to have the direction vector of the velocity and then rotate it 90 degrees as a unit vector, and then we want to project the acceleration vector onto that, which is then the dot product times that vector. But since I'm not working with the direction vector but with the full vector including length, I'm also so here and there I'm dividing it by the square of the length. Oh, that doesn't work. No, this is really weird. D0 is the direction vector of the velocity vector. Acceleration is something which is then should be projected onto the velocity vector rotated 90 degrees. So then you get a vector pointing that way or pointing that way, making an angle of 90 degrees. But instead we get this. Did it even compile? Looks like it compiled, so I don't get it. Oh, that's because whatever I calculated here, I didn't use it. I'm still plotting the acceleration vector. Yeah, I want to plot k, the curvature vector, starting in P0. The connector takes a from and a to. That's it. So I have to say go from P0 to P0 plus k. That should work. Yep, now it's 90 degrees. So this is the curvature vector, which should be 0 length, always perpendicular to the curve, of course. And if the curve is a straight line, this should be 0. So let's try to do that. Make a straight line. Nothing works. It doesn't have any influence at all, actually. Why is that? Don't tell me I'm still working with this. Oh, we are. Ridiculous. Okay, this is more and more straight. Apparently. No, now the length of it, the curvature is 0, like this. Put it like that. But yeah, kind of, you know, that's curvature is 0 when it is a straight line, that's clear. So if we make it very curved, it doesn't really get any longer like that. Yeah, now it gets longer. Much longer. So now it's very much curved. So it looks all right. And of course, if it is curved the other way, then it should point also the other way. It should also always point in the direction of the, well, wherever it curves around. But yeah, that should work. Can I make that? Can I make it curve the other way? What is this? It's a bit lame, but yeah, definitely now pointing the other way. I guess I can get a better feeling for if this is indeed the curvature. Yeah, no, maybe not. I mean, I could draw a circle that touches here and has a radius equal to 1 divided by this length. And that should be the, what is the name of that? Snugly fit a circle. But yeah. Not really sure how to test this. Could test it maybe like this. Kind of testable. Maybe you can see it now, or have to zoom in. Now you can see that the curvature exactly changes. The direction changes. Nice. Shall I do that? Or just, I don't know, to see how it looks like. Oh yeah, diagonal. Yeah, I'm trying to fit a Bezier curve through data points, basically. My own way. So I just need a circle. Let's use it, call it the plot curvature circle. Which takes, I guess, a center point. That's a tough one. And radius, length, right? Let's calculate it separately. Radius. Center and radius, and then a circle style. Do I not have a circle style? What the F? Just using a line style here. No. My line style is dashed. It's probably not what I want. Right, the radius is 1 divided by the length of k, which I don't know anymore. It starts to annoy me that I have to keep stuff in this scope alive. So I wanted to calculate stuff in this scope. Therefore I had a variable outside this scope which I can assign to, which then can be used here to actually create a connector with the lifetime of that thing, which was declared before this scope. But yeah, afterwards I don't have my k anymore. That's very annoying. So I want to define, I want to have the radius, I need k, I just need k, sorry. Let's declare that also outside the scope then. It's called k0, the curvature in point 0. And this becomes a plot p0 plus the radius times, oh, the length is already, so there's no radius here, just add k0. Now I might as well forget about this variable. Cannot default constructor vector. No, it draws it at the end of k. Yeah, no, of course. That was not correct. K is the curvature, not a radius vector. Thought it was the radius. Well, it looks like a very small circle. I would have expected something much larger. Very small circle. Definitely not correct. Not to mention, I don't see a circle at all anymore now. Where did my circle go? Why is this curvature vector so long? Doesn't make any sense. Oh, sorry, it was long because it's very curved, but yeah. Yeah, there's a circle. Nobody gets it. What? Maybe the circle didn't get drawn because center point is so far away. Or no. I still see it being drawn, but already now it's hardly visible with this length. So if this, unless it's very short, it's hardly visible. Absolutely not correct, I would say. Yeah. But let's go back to the web page. I don't think there's anything to see here, but that I don't already know. So this is what I want to do. I have a curve, and then this one has the same curvature for a long time. But anyway, the curvature at this point equals that one of that of a circle with the radius r, called the osculating circle. And my k is points in the same direction, but then has a length of 1 over that. Where it says if you have now plane curve, we have a plane curve, it's a curve in a plane, where that has a parametrization, which we have 2, except that in my case this is not true. But okay. I think you can just scale the whole thing. So this is the first derivative, x and y, and then squared, and then the summed, and the square root. That is the length of the velocity vector. And they want it to be 1, so I would say, well, then I just calculate. This is my d. The d0 is the vector that I am drawing, a unit vector. At well, and anyway, I draw one at point 0. So my d0 is the tangent vector given by the first derivative x, comma, the first derivative of y divided by the length of that whole thing. And then the curvature is given by the length of the second derivative vector. Maybe this is more interesting. General parametrization. Let comma t is x t y t be a proper parametric representation of a twice differential plane curve. Yeah, proper means that on the domain of definition of the parametrization, the derivative d, what is it, comma, dt is defined, differentiable and nowhere equal to 0 vector. With such a parametrization, the signed curvature is k is this to the power 3 divided by the square root times the power of 3. Now this you see again x, y, y, x, and then a minus there. So this is the dot product with between it's a dot product between the x prime y prime vector and the normal of the x double prime y double prime vector. But I'm dividing that by the square of. I don't have this to the power 3 divided by 2. Maybe that's the problem then. It seems so. Let's get the length then, so that's just the square root of this, the length of the velocity vector. And then to the power 3. So the V0 here is first derivative and A0 is the second derivative. And I take the dot product where one of them is rotated. It's definitely what is the enumerator. And then we have to multiply that with this divided by the length. Damn, man. Let's go all direction vector for a moment. To have the direction T0, V0 direction. And we want to do project the thing on D0 dot normal. And then multiply it with D0 dot normal again. Hello, JJ. Man, I'm messing up. I don't know. I'm just gonna go literally for this formula. X, just really bad, but afterwards you're gonna fix it, I guess. So it still looks the same, but then is in terms of dot products. The X times A0Y minus V0Y times A0X divided by the velocity times the velocity times the velocity. Well, that's just k, and I still need to multiply this now because I want to have my vector with the normal of the direction vector. So v dot direction dot normal. Well, that looks a hell of a lot better. Yep, so this is the osculating circle touching the curve, right? Looks good. And yeah, it totally looks good. That's more like it. Can really make it this small, yep. Small. On the edge. Nah, this is correct, right? It's really like following the curve for a while. It's 100% the correct one. If I just start it up without dragging, we have something that touches the bottom of my window of this curve. Okay. So now I'm going back and trying to use my dot product again. So I'm pretty sure that K0 is Yeah, this is V0 dot A0 dot rotate 90 degrees. Then the rest the same. Should still work. Except for the minus sign. The most lazy way. That's the same, right? It still touches the bottom of the window. So if instead I do not use, I see I should have rotated V. Sorry, let's do it different. So I'm gonna do A dot V. And I bet now I need 90 degrees again. Just that one. Yep. Okay, now I'm getting tired of this. This is line 163. So if instead multiplying this with the normal of V0 without taking the direction first, and then I don't have the normal, but that would be the same as here. Rotate 90 degrees. Now we get something that is longer. I still have to divide this by the length of the velocity. So that one, yeah. So I should have taken the square of the length of the square of the length. What I had before was just twice my velocity. Got to be divided 4 times. Right, so now I can divide this by the square of V0 length squared. Good. Yep. So now I can go back to my README. And fix that. Yeah, I thought I already had written down something. related to this, but I didn't. Didn't I not? Guess not. Oh, I guess I didn't. I guess I did not. Velocity vector. Just copy this. For now, it's just to 0. So this is the matrix where we have P0. I should look at this. Just written it out. We have P0 and we have P1 and we have the direction vector at P0 and we have the direction vector at P1. I don't think this is useful actually. I thought it was useful at first, but I changed my mind. I won't delete it yet, but let's make clear that this is a new chapter. And another new chapter here. I have a lot of craft here, man. Started writing stuff and then later, nah, maybe not useful. So what I want to do is replace the direction vector at P1 with the curvature at P0. Which means I have to go back to this one. Hello, Kim Jung Ji, I think. Mr. Kim. I think the curvature vector is not super important because it overlaps with the velocity vector. Or that actually I only want to have the direction vector, so say this. If you rotate that 90 degrees, then the curvature is either in that direction or in the opposite direction. So we can work with a sine curvature and then just say that that sine curvature times the direction vector of the velocity rotated 90 degrees is the curvature vector. So what I really want to add here is just a real, which can be positive or negative. You really want to float here because I'm just going to kick you. The curvature, therefore, is signed, and I get the signed one by using the dot product. So if I do not multiply this with V0 rotate 90 degrees, then I have to not divide this by the length, by one of the length. So this now becomes the length to the power of 3.5, I guess, 1.5, 3/2. I put Kim Jeng 5 minutes in a 5-minute timeout. Did he say something useful? Because the only thing I saw was empty messages that were repeated. Abhimanyu. I don't think he can talk yet anyway. Give it a few minutes. Yeah. To the power 3 divided by 2, or no, what is it? No, this is already the length of V. The length is 0, so this to the power of 3 then. No. So they use the absolute things here, and this is of course the square of the velocity vector, and then to the power half is the length, and then again 2 power 3 is this, thus the length of the velocity vector, aka the velocity, to the power 3. And this is the dot product, and I use absolute absolute value here because I just want to have the positive curvature, but I want a sine curvature. So I don't do that, I'm just using this value without the absolute value thingies, vertical thingies. Shall I use kappa because it's not really a K, right? It's a kappa. Oh no, we wrote a K here. They wrote a kappa here and a K here. I guess K is a sign then. K is signed. Sine curvature is K. Ah, right, good. Yeah, it is K. So the K of 0 equals obviously the A at 0. Dot well, it is not correct whatsoever. Okay, well, forget this. Let's just switch directly to sine curvature at t is 0 is now we can fill it in. So this is A0, this is not known, so I have to use this. X times the normal of, I'll write that out here, is, so V0 was V0 is this. And rotated 90 degrees is minus M11. Plus the other one times plus this. We don't do division, we don't do 3/4 or 3.5. That's what I need. I need 3.5. Nothing. Just does not exist. Is this correct? Just a single scalar, man. Hey, hi, Zas. Long time no see. Using, I don't know what to use it, but I want to see it anyway. What can we do with this? Now we know that. Okay. So after filling in this one, we suppose we still have one variable left. Now I have three variables, alpha and these two m's. And now if we put this one in, where k0 is then unknown, we have two variables left. So that still then allows me to add a p gamma. So I want to combine this with that. Where these are the only two unknowns. So it looks like I have to write that one. Or that one. So asymmetrical. Trying to think of a way to not break the symmetry between X and Y. We would just express this one in terms of that one. That's weird, you know. Or the other way around. Plus, I probably have to divide by one of them then. Where it is asking for problems. The point is that I want this matrix to have the same sign curvature at t is 0 as the previous matrix, the has at p is 1. I know everything about the previous curve, right? The whole idea is that I want to make this curve fit continuously and with the same curvature at the first point. The previous curve is already known, so I know the acceleration, the velocity, everything. And therefore I also know the curvature. You could calculate that if you just replace a 0 here with a 1, this part. But can't I just express this in a this. And this is the coordinates of P0, this column. This is the velocity vector, this column at P0. This column is the acceleration vector at P0. And then we have that if I project this onto the normal of that vector and divide it by the third power of the length of that, which is alpha to the power 3, then we must get a known constant. What does that exactly mean? Well, if you ask me, that means that I don't care about the acceleration in the same direction as the velocity. And that's my variable. So I do not keep this one or this one, but introduce a new variable, which is the acceleration in the same direction as the velocity. And that's arbitrary. And in the other direction is just fixed. So Mm-hmm. Am I overusing these things now? No, 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 no. Beta times that plus gamma times the normal of that thing. Just gonna write that as n0. Yeah, D0 and N0 are perpendicular. So they are a formal basis for any vector. And I just introduced two new variables, beta and gamma. They're not the same as whatever I used before. And then we have a random vector. So any acceleration vector A0 could be written like that. And then of course the normal is of D is just swapping x and y and making this one negative, as usual. And then we can fill that in. So the x-coordinate of that is beta times the x-coordinate of D0 plus gamma times the x-coordinate of N0. And the same here for the y-coordinates. And this is 2 times this column. Yeah, look like here. Well, at least in for t is 0, but well, we're only talking about t0 now. And one of these variables, I think, can be expressed into alpha and k0. And now we have only one variable left. That would be nice. And I didn't, you know, do anything asymmetrical. So, asymmetrical between x and, have a preference for x or y, I mean. So how do we do that? Well, I think just, you know, fill it in this equation so we get the k0. You already see one immediately drop out, that's why I did it like that. So you can do then k0 is dot product between okay, let's see. Yeah, noted whatever nv0. Yep, because this is the velocity vector, and that is just alpha times that direction. The d0 gives me the direction at b0. So alpha is the velocity. And this was a unit vector. So this is then the velocity rotated 90 degrees. So now I can fill that in this curvature formula. This is now the dot product between A0 and NV0. Which means the x coordinate of one of them, that is AX0, let's do it in smaller steps. Smaller steps, just begin with that, bullshit, is AX0 times NVX0 plus a Y0 times NVY0 divided by yeah, it's just alpha to the power 3. So that is then this thing times NVY, so that is alpha times the y of that one is alpha times wait a minute, NVX0 is alpha times the x coordinate of N0, which is that. Plus this one times, no, same thing, except the other one. Is, now things better drop out, or this whole idea was wrong. What is going to drop out? This should drop out, though. Beta should drop out. So here we have beta dx0 times alpha times dy0 with a minus. And I have plus beta times dy0 times alpha times dx0. Yeah, though that's gone. Now let's shoot slow. So that is then that times alpha alpha times beta times dx0 times dy0 with a minus sign. Then you have two minus signs, so plus alpha gamma dy0 squared. I can't shake the feeling that all the people that I show this that say, oh, way too difficult for me, and they hide their face, that if they would have tried this, they would have given up already. Like, oh, this is, oh, way too difficult. But I have this intuition, you know. It's not difficult. It's gonna be easy. It's gonna be something simple. I hope, anyway. I don't know. So yeah, alpha gamma minus drops out, dy0 squared. Good, 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 good. Plus, and then alpha beta dot, I'm deliberately taking the x first, of course, dy plus alpha gamma dot alpha times gamma times dx0 squared. All divided by gamma of alpha to the power 3. Yep, and now this drops away against that. And this becomes alpha gamma times dx0 squared plus dy0 squared, which is 1, because these are direct unit vector. So the result is gamma divided by alpha squared. And I was right. Beta dropped out, and it is simple. So I can, in this formula, I can just replace gamma now with kappa, with a k. And this is just this third column of the matrix. So you have here this. We can write ms. Let me just remove this because it was just so I could look at it. Now I have my acceleration vector, which is equal to 2 times this. So that is the acceleration vector divided by 2. So this is going to be replaced by something divided by 2. Being beta dx0 minus alpha squared times k0, that's comma, times dy0 divided by 2. And here we have that plus comma times dx0. And then I have to do the same thing here. Two. Now I can test this out, I think, by first making alpha and beta just a slider and then drawing the curve. And then seeing that, well, maybe even k0 as well. But then seeing that if you change alpha and beta, and then the curvature should not change. And if you change k0, of course, then the curvature should change. So I guess the next step is to use this matrix and then use and then draw it to test it, because you can always have made a mistake somewhere. With that matrix, I'm already drawing a circle now, right? For the curvature in P0. So we can immediately see if what is the effect. That's nice. The only thing I have to do is change this matrix. Alpha is again, I guess, going to be just my vector. Paste it in. That's not the one. It's like I'm missing a reel now. I mean, these two being velocities, I have here 4 reels. And here I only have 1, 2, 3. Mm-hmm. That's bullshit. Sorry. This is just 1. This is just 1 variable. This is a direction vector. So really, the alpha. No, sorry, that's not true then. The direction vector has an angle, so that's 1 variable. So these are 2 variables. Yeah. Yeah, a loss variable. Or not. And this is the most confusing part of the whole thing. That sometimes I'm like, what? Where did that variable go to? I don't get this at all. It's really like, variables gone. Damn it. Anyway, that's always this. We keep the velocity, so that would be alpha d0. And then, got to do that one. No, come on. Yeah, not even sure if this works. So a point minus a point minus vector, I think. Minus a vector. And then hope that the result is a vector the way I meant it. The thing that a point minus a point returns a vector, and then in the right way as well. So it should be 2 minus from, yeah. Point. Where's that defined then? So it returns a vector. 2 comma from. Yep. And then a vector minus a vector. Vector minus vector is a vector. Just subtract the second one from the first. So that does what I had in mind. Good. Me, I don't have used Emacs now. Hello, Jacob. Yeah, I don't know, man. Emacs? No, I use Emacs. I mean, I'm using Vim, and Emacs and Vim has been arch enemies since forever. I know that. So I'm in the VI camp, so I don't even want to try Emacs. Oh no. Yeah, good. You can't use Emacs and Vim. You can't use both. It's a religious war. I know very little about Emacs. The only thing I know is that it tries to be an application that you run and then you don't have to leave it anymore. You can do everything from Emacs. Everything. It's more an operating system, as it were. But I don't care. I'm leaving my editor when I stop editing. It's okay with me. Yes, that's what I said. As in, you never leave Emacs. You just do everything from Emacs. You want to watch porn? Just use the Emacs plugin to watch porn. Everything. I never use it, so I should shut up. But that's what I heard. But if it's true, it's a bit too pretentious for me. I think an editor should be an editor, not everything. You can read your email from Emacs. I think that was really like. I mean, isn't this the what is the word? Well, anyway, the thing that Richard Stallman wrote and is going for. And no doubt he started Emacs in the time that we still had black and white monitors of 24 lines and 40 characters wide. So not much room. And then yeah, no windows. So that's probably the reason he wanted to do everything from Emacs. Oh shit. My brother is sending me a message. Right. Looks like I have to go work at my parents again together with my brother. He's coming tomorrow. He's taking a huge risk sending me a message. Like I continuously watch that. He himself doesn't read it for a week sometimes. I use Telegram. But he's sending me 2 hours before bedtime a message that he's going and he expects me tomorrow as well. Oh well, I saw it. I definitely feel like hot chocolate. I'm going to do it today, finally. Yeah. Fuck C++. Hot chocolate is it. Is a new thing. If they coded ChatGPT correctly, and then it would say when you ask a C++ question, have you tried hot chocolate? So what we need is this. Caramel. Yeah. Yeah, I mean, yeah. You already got the gist of it. Right. Alpha is the length. Alpha is just the velocity. Let's see if I have a V0. I see that here. Alpha is the length of V0. What do I have in terms of V0 length? Yeah, no, not really. I'm just gonna do the alpha double alpha is V0 length. So I just need two sliders for K0 and for beta. I erased all slider code. There, sliders. Well, ain't it interesting? D1 is uncoupled, so let's remove that. Don't see it anymore. Okay, nice cup of hot chocolate. And it looked good already, right? I mean, this is the oculating, what the fuck was the word? Let's change K. Hoppa. So we make K larger, the curvature is larger. And it's definitely more curved. Yeah. Why do I never I never seem to make any error in the mathematics. Like an hour of formulas and then I coded and there's 0 mistakes. What the fuck, dude? It's just scaring. Beta's not doing much, is it? It should make this slider go from over larger values, I guess. And most importantly, the diameter of the circle, aka the curvature itself, is not changing. This is just the curvature at P0. You better accept it. That's pretty awesome. Pretty awesome. Yeah. By now I'm convinced that the code is correct, the formulas are correct. Okay, so the idea is that we set direction and curvature at P0. Then it has something like, okay, this is curvature, this is the direction. And then we have to go to P1. So now we are in P1. And then the only influence that we have is beta. And that's currently hardly doing anything whatsoever. So let's begin with giving that a lot more value, possibility. Okay, it's really. Oh, you want that curvature? No problem. Get away. It's just really shortly that curvature there. It's ridiculous, of course, this. Wait, yeah, it's what you asked for, it says. I really wanted to go below 0. Why is that not possible? Oh, I'm an idiot. I am an idiot. This is the minimum value. Minus and 0. So it starts at 0, but then we can go to minus 1. Minus 100. That's better. Minus 100. Yeah, now at least I can get to PV. I'm pretty happy if I can cover the whole thing on this side of P1, so that's possible apparently. Can even go back. Yeah, I'm not. I mean, you can even go further back, but this starts to become really ridiculous, as you can see. And this way, you can go even this way, but yeah, also it's ridiculous if you want that curvature. Apparently. Make the curvature less smaller. The curvature larger. I mean. More curvature. Somehow I'm not happy. I can't even make something that looks like a smooth curve through P0, P1 and P cover. I think the problem is I can't make the curvature large enough. Small enough. I mean, I can make it small, but what the fuck is it doing this overshoot? Was it not just going like zip? Yeah, like that, exactly. Like that. I definitely need to be able to make K0 smaller. I did that one the wrong way as well. And I did. I wanted it start at that value and then allow me to go really small. Yep. Well, beta is especially able to reach this part. Well, like below P1 than above it. But yeah, that's the result. You want to go above this line, then you really have an S shape. And it has definitely a problem here using the curvature here, and I mean it's already almost a straight line going upwards, this hill here, and then it has to break free from the circle and go through P1, and then I wanted to go up again. That's just too much for a cubic Bezier. Can do it, but then you have something really, really shitty here. Touch and go. Ding. And that way we can get there. Yeah. Well, of course, what you would expect is, yeah, well, I don't know, something like this. Okay. And then just smoothly go to P1. And then smoothly go back to P, or something like strange. Like bending a piece of metal. This is really bad, man. This is nothing like you want. It's extremely sharp turn here. It's pretty useless. I need a zoom. No, I'm not using Wayland. I don't even. I think there was. Maybe I once read something about why they wrote Wayland. Is there some kind of legacy problem with X11 that I try to solve? But it's not going all that smooth, it seems. Sometimes you hear people talk about it and it's always Wayland problems, or at least something that works on the X11 that doesn't work on the Wayland. Because so much is written for X11 that they wrote compatibility layer. So I guess most of those complaints are about X11 applications not working through on the Wayland through this compatibility layer. This didn't have something to do with a security issue? And no X is extremely insecure. It used to just listen publicly on an IP address. And then anyone connecting to the same address could see your keystrokes. That was a really amazing security. So that they patched that by not even allowing the server to listen on a socket anymore. You can only listen on something local that you can only connect to when you're local. But yeah. I feel like quitting for today. Kind of disappointed with this outcome, man. And the next step would be to have the beta automatically adjust automatically, such that the curve goes through P gamma. Yeah, this P gamma, of course. Oh, now it goes through it. And then, are we happy with this? Are we happy with this kind of fitting? Makes no sense whatsoever, man. The original curve probably came from here. Look like or yeah. This side kind of looks smooth though, as in, if I would just not draw this part, if I would not see it, would I then be happy? Maybe. Because my objective was to find the direction and the curvature in this point. Yeah, I would still plot this. It would go like this and then continue like that. But then if the next point is there, yeah, then I wouldn't have used this. I would have used this. This would be visible. I would not be happy. Absolutely not. This is absolutely ridiculous. It didn't even get to that point. How is a cubic Bezier not able to go through this point, and this point, which are almost on one line, given that the curvature is like that? Plus this is a signed curvature, I should bloody make it, be able to make it negative. X leaking memory. Oh, I never have leakage from X. Must be some application. I'll leave my PC on for weeks, months, sometimes. And memory is totally stable, so no leakage whatsoever. Yeah, to be expected. Okay, I'm gonna I might have 32 gigs of RAM, but it still doesn't leak if you can run for a month on a time without noticing anything. 4 gigabytes is just not enough. You can't run a modern computer on 4 gigabytes of RAM. I wouldn't call that leaking then. It's just using a lot. Yeah, if you look at the Chrome applications that I'm running. Discord, Chromium, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, only 17. Thought I'd like way more. Thought I was running something per tub. More tubs than 13. That isn't very long at the moment. Rebooted recently. Do I have a command for mem info? Nope. I'm gonna quit for now. I don't feel like coding. Let's lose a game of chess. Light chess. Yeah, just type an L and now we have it. 10 minutes. Oh, that's a bit short. Okay, let's do 10 minutes. There's a question mark against question mark. So if I lose this, I'm gonna drop below 2000. Yep. I don't think I had anything. That's it. Analyze this. End position. 0.0. White is better. But the exchange screen's giving me a draw. And I guess I should be happy. So this was a bad move. Gives away 2 points. I had these lined up so that, you know, I cannot take with this one. But if I play now, it just takes it now. Here I'm better. I should already. Why give away this pawn? It just takes it like that, and then. That makes sense, I guess. Takes a knight. So he has to take, and then I get a horrible grip on this point, which should not make him happy. Kinda has to put the bishop there, and I just plant my knight here, and if he takes, I take with my bishop. Yeah, didn't do that. Still better for me if I just take it. It's gonna minus a half since a long time. Oh, here I give it away, my half. Should immediately take with the pawn. Yeah, this knight is pretty good then. Still a good knight. The knight that cannot be chased away. Should have taken with the pawn. Now I lost my knight, so now taking with the pawn is just stupid. From here it's just a draw. Slightly better black, not really. Now I can, for the first time I can push this pawn. I really want to see why. He takes it like that? No, let's take it like that. Oh, that becomes a weak pawn and he can't defend it. I'll give away another pawn. Typical computer shit. Then I can pick it back here with the check here. Oh yeah, right, okay. Devastating move. Okay, this breaks up stuff. Oh, and that one, yeah, no, of course. Is there any other move that is good than moving this? What about taking that pawn twice? Not as good. He's coming out with his king here. an instant minus 1.7. Starting with giving away a pawn. I really need a pattern recognition, man, to see this. Why is that good? Okay, give a check then, but I like getting in with my rook, but let's say, okay, let's see, it's not even sure. If I take like this, then the trick is no trick. Take that pawn, he just gives the pawn back. King runs like crazy, we get a pawn back and still 2 points up. Why? How? Defends that pawn? Nobody sees it. -2, why? Was there a free pawn? Queen is trapped, maybe? It's trying to escape. Jerk. It doesn't even take... Oh, it has to defend that one, yeah. Now take it to the queen. Then we come inside. Got to admit that. Going in a check by himself. Change this pawn. Do not take back. Hello, Koto. I cannot imagine a game, a real life game, where I would not have taken back. I would have taken back instantly. And the computer tells me that I have to move it back. Why? Okay, I'm gonna take it, see what happens. Minus 2.7. It was the better move. Try it again. So going back is minus 2.3. And taking here is minus 2.7. But this is the move that you should do. Okay, what happens if I actually go there? Minus 2.3. Minus 2.2. Minus 2.3. Minus 2.2. Minus 2.3. Back. Take there, my move. Minus 2.7. It's better for black, man. Why does the computer want me to go back when this is just a way better move? Okay, he's gonna go there, instantly exchange that, of course. And then we win another pawn. And another pawn. Now he's doing it again. What the hell would I move my bishop? Oh, I can't even give check, because I just win this piece here. So he has to go back and then I can start walking. Yeah. Maybe. Well, this guy starts walking too, and I walk, and they walk. They give up walking. They see that it doesn't help. Goes there. I don't feel really attacked. Why not just take here, exchange everything, and then... Oh, then still nothing. He wants to play that. Makes sense. The king goes into attack mode. Or not. Or maybe... And then I'm not playing this because... I'm playing it anyway. Oh, I lost the whole point. Of course, now I can go there. And now I can't play this anymore, or what? Oh, now I can't defend it. Well, but I can defend it. And then he's attacking my rook or not. He's attacking this pawn. Attack the pawn. Okay, that definitely sucks. There's no promotion anymore, is there? Let's not take a ponderous check. No, let's double the pawns. Blocking my rook. Losing equality. Is the computer for real? Of course I would take your check. No, oh, then lose this pawn. Yeah. Nah, yeah. Yeah. But this thing is pinned, man. Don't give away. This move here, I mean, what? Oh, I'm losing the pawn anyway. Maybe that's the reason. So I take it, but then I lose my quality. I'm gonna take it. This is what I would do. Minus 2.7. And I made it a draw. Whoa. You gotta be kidding me, man. That is difficult stuff. What the hell just happened? What the hell just happened? Why is this a draw and the other one isn't? Move the rook, we check. Why I cannot just move back and defend my pawn? But you can't take it anyway. Okay. Trying to promote. Blocking this free pawn. Taking my other pawn. The king is strong. Defending my pawn, stopping promotion. This king has a really long journey here. Jerk. Let's go in front of the pawn. Let's go back. Nobody gets this. Yeah, but like that you get a draw. It just wants to prove that it is a draw by giving away pawns. Okay, it's defended. Never mind. Stop the promotion. It was already stopped, but yeah. Let's threaten mate. Stop the mate. Threaten to take this pawn. Let's do nothing. Let's actually take the pawn. Let's, I don't know, exchange everything. Okay, well, nice. I don't know, but here we are winning. And if I take the pawn, we are not winning. So I should have taken it like that, giving away my rook. Well, obviously we start with looking at taking the rook. Oh, I take that rook. Oh, indeed. Not really losing my rook. Stop progress. No, take it. So winning here, but why? Why am I winning? There is no difference with the previous one. I also had a free pawn there. Okay, this one is already almost at the other side. The other one was still here. King comes closer. We eat everything. Okay, so let's do a stupid move here. Why not this? Oh, because that gives away the bishop. King goes, why not king there? Check. there. King really has to come closer. King goes there, king goes there, king goes there. Promote with 2 pawns, or 2 free pawns. Definitely makes a difference. No, okay. One of them is going to promote, I suppose. But how does one see that in this position? How does one see that? That's a draw and this is wins. I don't see it. I don't understand it. I will never see it. F takes e4 is absolutely the best move. And then we have possibly rook c3, as in not doing anything, but also not destroying it. Go behind this pawn. No. Rook d8. Retreat, retreat. No, it really is f takes e4. What is the winning move? Why? This is not a good move going out of the check. No, because then I can give check like that. Okay, then if I go back, it's completely cutting the king off. Go forward. Oh, that bishop here. Go forward again. Now it's a mate threat instead of giving check. Okay, so let's not lock up the king on that file then. Go there. Yeah, well, I don't know. Did you quit? Quit. Quit. It's not a quit game. It wants me to quit. You can't start a new game. Good night, people.